Hello, everyone. It's now my turn to talk for about 20 minutes. And I promise to show you a cat picture and also tell you about how to easily set up machine learning model monitoring with Toloka. To be precise, it's called human in the loop monitoring, if you want to be fancy. So I don't have a slide about my spectacular career, so let's get to the point. What is it? Machine learning model monitoring, and why do you maybe need it? Well, it's basically the most overlooked step of the machine learning project lifecycle. So you develop your model, you collect the data, you select the best model among all the candidates. And if you deploy the model to continuously serve some predictions to your users. So if your case is not like you just have some data set fixed and you just run your model once, then you need model monitoring, because after you deploy your model, after it starts serving actual data from actual users, it can break down. It can break down in such ways in which the usual software does not break down. And the best example I know is very recent, and it's a famous story. It's about scented candles and COVID. So basically, you can find some scented candles on Amazon, and you can find a very, very strong regression correlation trend as observed on the plot on the right. That when COVID is rampant, a lot of people start leaving reviews about these scented candles, saying that the candles don't have any scent. Well, that's obviously because people are losing their scent due to COVID, and they don't understand it initially, and they blame the candles. Well, and what does it tell us about machine learning? I think it's a great example of a very hard to detect problem with your data. So the reviews before COVID and after COVID, they did not change. People were saying, well, in the same words, basically earlier and now, they were saying that some candles do have scent. They were saying that some candles don't have any scent, but actually the data has drifted dramatically because of outside forces. And you cannot detect it in your data alone. So before COVID, you would see a review that says that a candle does not have any scent, and it would mean that very likely the product is bad. So basically the conditional probability, the one your model is learning, well, it was very straightforward. But after COVID, you have the same reviews, but if people say that a candle does not have any scent, well, it does not necessarily imply the product is bad. So the reviews didn't change, but the data drifted. And if you train, say, a new model on this data, well, it will have a very hard time. So how do we protect ourselves from such cases and other cases? Well, you could monitor your model. The thing is that real data, it changes over time. So say, for example, your product, it was opened to a new market. And now new users are flowing in and they are doing something different with your data. Now you have distribution shift, that is, your data changed and maybe your model is not adequate anymore. There are also a myriad of other possible problems that could arise. So for example, maybe your training data was initially not representative of the test data. And after you launch your model, well, it was perfect when you were developing it. The metrics were ideal. Everything was great. But after you launch it, it can break down. And you need monitoring to know if it does its job well. And you need to continuously watch the metrics because you never know when and for what reason it can break down. So how does one implement this kind of stuff? The typical inference process of an ML model looks roughly like this. So here is an example for a computer vision model, say a classifier. You have some input images, you have some model, and you have some API above this model. The images are sent into the API, it calls the model to get some prediction, and then it usually saves the prediction and the image, maybe a sample of them, to some database so that you can evaluate them later. And only after this, it returns the prediction to the user. Now, if you have this kind of process, you can very easily set up a monitoring process by using these saved predictions in the database. But here's the question. So you have the predictions of the model, you have the images, but you don't have the right answers. How do you know if the model was right or wrong on these images? Obviously, you need to get the labels from somewhere. And here's where you can, as one of the options, use humans. You can ask humans on what they would say about this image, or you could ask them if the model was right. It's two ways of doing the same thing. And you can ask humans using Toloka, which is very handy for a couple of reasons I'll outline later. If you would do this, well, the process would look like this. It would be completely parallel to your inference process. You could run it at any time. And here is what it consists of. So first of all, you need to set up the machinery, the Toloka stuff, including the Toloka project, the pools, and so on. It's the step 0. So you use the Toloka API or maybe the interface to set up your Toloka project where you will send stuff for the labeling so that you can compute some monitoring metrics. And then it's really simple. When you want, so maybe once a day, once an hour, it depends entirely on your use case. You take the predictions from your database. You take the model predictions, maybe 2 if you want to use them. But the simplest way, just take the images that you have saved and ask the crowd to label them. After you have done this, you have some kind of right answers for the things your model has been answering to. Now you can compare the labels from the model, the labels from the crowd, and compute some monitoring metrics. If you do this periodically, you can, you can track the metrics in time. You can basically plot it on a dashboard and detect by eye when something goes wrong. So yesterday, everything was going well. We had the F1 score of 0.9, and suddenly we have 0.6 today. Something changed. Well, usually it's not so dramatic, but you get the idea. Now, why Toloka? I especially like Toloka for this use case because I come from the engineering background, even though I'm the research now. And what I like is when code for everything is alongside the project code. And Toloka with the Python client, with the API, it allows you to store the code for setting up the project, the code for running this whole monitoring process, and the code for displaying metrics, all alongside your model. So it's very easy to maintain. It's all interconnected in a good way with low coupling. And it's not like a separate thing that separate people maintain and it turns into a mess. Also, Toloka is very fast, so it happens basically almost in real time. You send stuff for the labeling and it's done. You can watch it getting done. And it's, of course, way cheaper than having your own assessors and whatnot do the same job. I have prepared a small project. It's basically a toy demonstration of this whole process, including the model predictions and the monitoring process. It's a toy model that does the following. So it is a CV problem that handles classifying cat and dog images. You have the model, you have the API, and you have all the code to set up the stuff in Toloka. Let me just show you the stuff. I will not run the whole monitoring process now. Okay, let me switch the sharing to my browser. Now this is where you can find the example project. It has a very readable README. I'll partially go through some steps of it, but not all of them. So if you want to run it at home or try it out, then you can just follow the steps where you will get the model, you will set up the Toloka project, and finally you can call a script that does make some example predictions, and compute some metrics. And finally, you can see the metrics under this link. I'll show you a working part of it. But first of all, here is a cat picture. I'm sure if this was a crowd pool, we would all successfully answer that it is indeed a cat, though though it really depends. Now, if you run the example project, you can see the API with some interactive documentation. And how it works is that you have this API to the model. It's just one HTTP method. You take the link for some image, you press this button to try it out. And what you do is you send a post HTTP request with the URL to the model, like, give me some predictions. And it does, hopefully, it does. You could also do it in your console command with your browser and whatnot. And what you get is that the prediction has been saved to a tiny database, and here is its unique ID. And also it has been, the predictions have been returned in the form of some probabilities, and the model is correct. Now, if you run the attached, the included into the project, let me show you the stuff, this script, after you have set up the Toloka project. Well, it will take a small sample of predictions. In this case, it will take the last 10 predictions from the database, which have not been labeled. It will send them to Toloka project like this one, where it will create a pool and create some tasks for Tolokas. And then it will wait for the labeling to complete. What happens inside is that while people will be labeling pictures, I have prepared this demo scenario where there are some obvious answers, and there are some harder examples, and we just let Tolokas pick what is the label with the added option of specifying that neither label is correct. This could be useful in the case where you want to monitor that your model, for example, is not being adversarially attacked. So if you detect that a lot of stuff that has been sent to your model turns out to be nothing related to your use case, well, it's time to get worried. And with monitoring, you can actually see when this happens. So after this has been done labeling, some metrics are computed. And in the end, you will see on this page, which is currently not active because I'm not gonna run the whole process here. Don't want to keep you waiting. You'll see a plot like this. Well, it basically displays your F1 score for each time you run the compute metrics routine. And that's about it with the small demonstration. Let me share the presentation again. Here it is. Now to some caveats. So while it's very useful to monitor a metric, first thing I want to say is that while in my case, I do monitor F1 score, but it's a very simple example. And in reality, you would be better monitoring a few things. First of all, you have to account for the fact that the metric can move, can change from time to time, and not only because of objective changes in data, in your model breaking down or something else, but also it might be because of annotator responses. So it does happen, maybe the control tasks of your project have been leaked or something else happened. And that means that you have to monitor the annotator quality as well. This is some added complexity, but well, it can, in a lot of cases, be very much worth it. What you could also do is take into account that maybe since, for example, your project annotators have their own metric of accuracy or something, maybe not all changes in the final metric are significant. So the maximum, absolutely best way to handle this would be to do a lot of statistics and find what kind of change from time to time is significant given the variation introduced by annotators. But you could also get away with just adding some error bars and or simply using the confidences you obtain from aggregating annotator responses as sample weights when you compute your metrics. So you don't want to penalize your model for being wrong if a lot of annotators did not agree on some example. So it's probably some kind of a bad example, and you don't want the model to be very confident about it. As for most other KVs, and I'm sure you are thinking there are a lot of them, most of the other details are very specific to each use case, and they are not covered in the starter project, but you can use it to start your own routine. You can use it as a foundation, as a base, to just see an example how it works and then go from there. And that's it for me. So do you guys have any questions?
Thanks, Boris.